1100. And we are going to look at the calculus. Specifically on the differentiation of trigonometric functions. Trigonometric functions. And there are so many ways of how we can differentiate these trigonometric functions. We have the first principle, we have the product rule, we have the chain rule, also the quotient rule. We can use all those methods. We are going to look at the first example. Okay, so the first example is this one. We say differentiate f of x, which is equal to sine x. Now, this one we are going to use the first principle. And differentiating using the first principle, we are saying the f prime of x, which is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is the first principle method. Now, we are going to differentiate the sine x using this first principle. Now, we are going to replace the sine here as h approaches 0. I'm going to say sine x plus h, then minus the same function, which is the sine x. Then we are dividing this by h. Now, we look at this part. Under trigger identities, we know what to say. It is the same as take note of this. We say sine A plus B. This is just the same as sine A cos B, then plus cos A sine B. And we can relate this to this scenario. So we're going to say this is also the same as sine x plus h, which will give us, we have sine x cos h, where there is a we put x, and where there is b we replace with h, as we have been given here. So we have plus cos x, then sine h. So this is just the same as this one. So in here, we are going to replace with this for easy working instead of this. we continue, say the limit as h of, now remember, we are replacing this one. Okay, so we're going to say sin x cos h plus cos x sin h. Then we have minus sin x. So minus sin x. Then we divide this by h, like that. So now, having that, we can see that the sign, we have interest in the sign, sin x, sin x. I think we can group this. So in the next stage, we're going to say the limit as h approaches 0, bringing the sin x, cos h, then we bring in this minus sin x. Then we have this one plus cos x sin h, of which everything is divided by h. And we can see clearly that sin x becomes the common factor between these two terms, and we can factor it out. So here we are going to factor out the sin x. We have the limit as h approaches 0. We have sin x, open bracket, we have the cos h, then minus, here we're remaining with a 1. Then plus, we have the cos x sin h. Everything divided by h, like that. Then now, we have two functions here. We can separate this. So we are going to have the limit as h approaches 0 of sin x cos h minus 1 divided by h plus the limit as h approaches 0 of cos x sin h divided by h. And now we are interested in the functions with the h. Now we are going to treat the sin x, which has no h, more like a constant. So we are going to factor out this, saying sin x limit as h approaches 0 of cos h minus 1 divided by h, plus we factor out the cos here, it has no h as well. Then we have cos, the limit as h approaches 0 of sin h divided by h. At this level, we know what to say. The limit of sin h divided by h is simply 1. But on this one, we can check by using the conjugate method. where we can multiply this one to say, take note of this one, cos h minus 1 divided by h. We can multiply this by the conjugate of cos h plus 1 divided by cos h plus 1. And we see what it will give us. So we have this one, it will give us simply cos h, cos squared h minus 1, then divided by, we can say h cos h plus 1, like that. And this, going by the identities, we know what to say. This is just the same as negative sin h, negative sin x, sin squared h, which is just the same as cos h plus 1. Now, this can be written as negative sin h divided by cos h plus 1, and also sin x divided by, sin h, since we are using the h here, divided by h. And if you look at this one, if we take the limit of this one, we are going to get a 0, because the limit as h approaches 0, it's a what? It's a 0. And this one is going to give us a 1. So this one is simply going to give us 0 multiplied by 1, which is equal to 0. So we know to say the limit of cos h minus 1 over h is simply a 0. So now, from this stage, we're going to say sin x, and this one give us a 0, then plus cos x, then we have a 1. Now, from this system, we know how to say sin x multiplied by 0, it's a 0, plus cos x multiplied by 1 is simply cos x. Therefore, you know how to say that f prime of x is equal to cos x. And we are going to be taking note of these answers here so that we make use of them as we go on. We know to say the derivative of sin x has given us what? Cos x from the example 1. Now, we can proceed to example 2. Example 2, look at differentiate. Differentiate f of x, which is equal to cos x. That is another example. pause just for half a minute so that those who are following can try this one, following the process I used on the example 1. See if you can compare with what we are going to do. You can try it on your own. We see what you can come up with on this one using the first principle. Using the first principle. Okay, so now we can do it together. Solution for this one. The first principle, from the first principle we know to say when you're deriving a function using the first principle, we say f prime of x is equal to the limit of f x plus h minus the f of x divided by h as h approaches 0. So now we know to say the next stage is replacing with the function which we have been given in this question. So the function we've been given here is cos x, which is our trigonometric function. So we have the limit as h approaches 0 of cos x plus h minus cos x, which is the function itself, divided by h. Divide everything by h. Now, on this one, let us take note, just like we did on the first one, we had this identity concerning sine. So we also have another identity concerning cosine on the expansion of the cos x plus h. In terms of the a and b, we have the cos of a plus b. This gives us cos a, cos b, minus sin a, sin b. Now that we have, in terms of x and h, it means it's just replacing in that identity. Where there is a, we replace it with x, and where there is b, we replace it with the h. We have cos x, cos h, minus sin x, sin h. So we know what to say. This is just the same as this. So now we are going to replace this where the cos x plus h is in this function. So we have the limit as h approaches 0 of cos x, cos h, minus sin x, sin h, minus this one now, we have cos x, divided by everything by h. Now, having this, we are interested also, if we look at the cos x and also cos x, these are like terms, so we can group the like terms. So we're going to say the limit as h approaches 0 of cos x cos h minus cos x and minus sin x sin h divided by h. Don't forget. Now, we can factor out the cos x. We have the limit as h approaches 0. We have cos x, then we are remaining with the cos h here minus 1 minus sin x sin h. We divide everything by h. Now from here, what next? From here, as we did to this one where we separate the limits, because we have two functions now, separate functions, so the limit can also be shared. We have the limit as h approaches 0 of cos x. Then we have cos h minus 1 divided by h minus the limit as h approaches 0 of sin x sin h divided by h. Now, here we can treat the cos x and the sin x the other side as constants because they do not have the h in them. So we can factor them out. Cos x limit as h approaches 0 of cos h minus 1 divided by h, then minus, we have the sin x limit as h approaches 0 of sin h divided by h. At this stage now, we are going to simplify the limit. We know from the previous example 1, we worked out this one, where we had to conjugate it here. I'm sure you can remember, where we got this one as 0. So the limit of cos h minus 1 divided by h gives us a 0. So this one is going to give us a 0. Then we have minus the sin x and the limit of sin h divided by h gives us a what? A 1. So this one is going to give us a 1. Having this one is going to give us a 0 minus sin x. Sin x multiplied by 1 is simply sin x. Therefore, we know to say the f prime of x gives us the negative sin x. This is the one. Remember I said we are going to be taking note of these answers. They will be of help where we are going. Cos x, this one gives us negative sin x, like that. Allow me to clean this one, this part, so that we continue. We're doing example 2. Now we're moving on to example 3. Example 3. Differentiate f of x, which is equal to tan x. Tan x. Tan x. We know what to say. We know that our identities, tan is just the same as sin x divided by cos x. Now, we're going to use this in order for us to differentiate this function. We're going to use that. And remember I said we have so many ways of differentiating trigonometric functions. The first one I said was by using the first principle, and I said the quotient rule, the product rule, the chain rule. All those are methods or ways which we can use in order for us to find the derivatives of the trigonometric functions. Now on this one, this division means we're going to use quotient rule. We're going to use quotient rule. Now, for easy calculations, I'm going to say let u be equal to the sin x and v be equal to cosine x. So du dx is equal to du dx. Remember, I said we should keep track of those. Du dx, we have, this is a sign. We cannot go through using the first principle again to find the derivative of sine, the derivative of cosine, so that we can find the derivative of tan. So we worked them out already. By now we should be able to say the derivative of sine x is simply cos x. The derivative of cos x is simply the negative of sine x. So this is the knowledge we're going to use here in order to simplify things. So we know to say the derivative of sine x, which is the du dx, derivative of u with respect to x, is simply cos x. Same applies here. The dv dx is equal to the derivative of cosine x is simply the negative of sine x, like that. Okay. So now, we clean this part. So, finding the derivative using quotient rule, we say the f prime is found by, or the derivative of the function with respect to x is found by, we keep the second function constant, then derive the first function with respect to x. Then minus, we keep the u constant and derive the second function with respect to x, then divided by the second function squared. So now, we are just going to replace, since we made our job easy by finding the derivatives in advance for the first function and the second function in terms of sine and cosine. Now, what is our v? Our v is the second function, which is cos x. So we're going to write cos x here. Then the derivative of u with respect to x, derivative of u with respect to x is cos x. So multiply this, or we use brackets here, cos x minus, we have u, we keep u constant, which is the sine x, u is sine x, so sine x, then multiplied by the du dx, or dv dx, sorry. So dv dx, our dv dx is negative sine x. So negative sine x. Then all this divided by our v squared. Our v squared. So our v in that case is the cos x. The cos x. Now, we can simplify this. Cos x multiplied by cos x, it simply gives us cos squared x. Then negative sine x multiplied by negative sine x. This one is going to give us plus sine squared x divided by cos x squared, can also be written as cos squared x. Now, this is an identity. Cos squared x plus sine squared x is simply giving us what? Simply giving us a 1 divided by cos squared x. And now, 1 divided by cos squared x, this one simply gives us sec squared x. So we're going to say, therefore, the f prime of x is equal to sec squared x. So when you differentiate time, x simply gives us sec squared x. Now, this was the example number 3. We can move on to example number 4. Example number 4. Example number 4. Okay. So here. Okay, so example 4. Differentiate cot x. So now we know to say cot x is just the same as 1 over tan x. Cot x is just the same as 1 over tan x. Now we know tan x is just the same as sine over cosine. Meanwhile, it is 1 over tan x. It means we are going to say this is the reciprocal of tan x. So we are going to say cos x sin x. So now, differentiating that one, it means what are we going to use? We are still going to use the quotient rule. We are going to use the quotient. Quotient rule. Going to use the quotient rule, just like in the previous example. Now, how do we use the quotient rule? Say the f prime of x is equal to, we keep the second function constant, differentiate the first one, minus, we keep the first constant, differentiate the second one, divided by the second function squared. And we are saying, with it, the first function be equal to u, which is the cos x in this case, and the second function, let it be v, which is the sin x in this case. Now, the u prime in this case, remember the first one I used the dx, the u dx, and the v dx, but now we need to use this one also because u prime is just the same as the du dx. We are differentiating. All these symbols mean differentiation. So now, u prime is just the same as this cos. Just come again. We can go through using the first principle again to find the derivative of cos. So the derivative of cos, we know now that it's just the negative sin x. Then the derivative of sin x, we know to say it is simply cos x. No need to waste time. This is where we're coming from. Now, applying this way, we're going to say, therefore, continue, our v is sin x. And our u prime is negative sin x, like that. Then minus, what is our u? Our u is cos x. And what is our v prime? Our v prime is cos x, like that. Then we are dividing this by the second function squared, which is sin x squared, like that. Now we can simplify this function. We have sin x multiplied by negative sin x. We are going to have negative sin squared x. Then minus cos x multiplied by cos x, we have minus cos squared x. Everything divided by sin squared x. Remember, sin x squared is the same as sin squared x. Okay. So from here, we factor out the negative. We're going to say minus. We have sin squared x plus cos squared x divided by sin squared x. Remember, we have the identity. Sin squared x plus cos squared x is just the same as 1. So we are going to have minus 1 divided by sin squared x. But this, therefore, our f prime of x is going to be, what is the 1 over sin squared x? This is just the same as cosec squared x. So we're going to say this is the minus cosec squared x. Ends there. So remember, said we are going to be keeping track. So we're differentiating cot So we're saying the derivative of cot x with respect to x is the same as negative cosec squared x, like that. Okay. Can I grab this side? This one was our example 4. So our example 4. Okay, we can look at one more example. Example 5. Differentiate f of x is equal to sec x. Sec x. So solution. This one, we know how to say sec x is the same as 1 over cos x. And this is another quotient rule, where we have, we can say let u be equal to 1 and v be equal to cos x. And what is our u prime? This one is simply 0. And what is our v prime? Is simply negative sin x. Now, using the quotient rule, bring in so we are saying v, we keep v constant, differentiate the u minus u constant, differentiate the v divided by v squared using quotient rule. Now, what is our u? What is our v? Our v in this case is cos x, which is our v. Then what is our u prime? Our u prime is what? Is 0. Then minus, what is our u? Our u is a 1. Our u is a 1. Then we have our v prime. Our v prime is our negative sin x. Negative sin x, like that. We divide by our v, which is the cos x squared. Now, cos x multiplied by 0, this one is going to give us 0. Then we have negative 1 multiplied by negative sin x. It gives us plus sin x. We divide this by cos squared x. 0 is nothing. We're going to say this is sin x divided by cos squared x. And this can be, the denominator can be separated. where we're going to have sin x divided by cos x. Then we can say this is 1 divided by cos x, like that. This one we know from our identities to say this is our tan x. And this one we know. This is what? This is simply sec x. So we know to say if we differentiate this function, which is the sec x, we're going to get tan x sec x. So we can also keep track of this, where we say the derivative with respect to x of sec x, this one gives us tan x sec x. Okay. So in the next lesson, we can continue with the product rule. We also have the chain rule. But for today's session, I think we can end here. Thank you.